Have you ever really thought about it? You click on a link and literally the blink of an eye, information from a server maybe halfway across the planet just appears on your screen. It feels like magic, right? Well, it's not magic. It's all built on the fundamental rules of computer networking. So let's pull back that curtain and see exactly how the trick is done.
So seriously, how does it work? How does that one single click, that tiny request for information, navigate this massive global web of cables and devices to find its destination and come all the way back with an answer, all in less time than it takes you to blink? That's the big question we're going to unpack today.
At the end of the day, it all boils down to this one simple idea. A computer network is really just a group of computers that are connected so they can share stuff. That stuff, that resource, could be a file, a printer, or, in the case of the internet, access to a whole world of information. It's all about connection and sharing.
All right, so here's our game plan. We're going to start with the absolute basics. What is a network? Then we'll scale things up, going from personal networks all the way to global ones. We'll meet the hardware workers that make it all happen, look at how data physically gets around, and then we'll wrap it all up with the big picture takeaway.
Okay, let's start at the very beginning, the foundation of it all. What really makes a network, well, a network?
You know, this whole thing had to start somewhere, right? Well, that somewhere was ARPANET. This was the pioneer, the granddaddy of the internet. It was the very first time anyone linked multiple computers over a long distance to share information. And it totally set the stage for everything that came after.
Now, not all networks are created equal, not even close. The biggest difference between them is scale, how far they can reach. So let's size up the digital world.
So we start at the smallest scale imaginable, a PAN, or Personal Area Network. This is your own little tech bubble. Think your phone connecting to your earbuds with Bluetooth. It's just for you. Scale up a bit and you get a LAN, a local area network. This is what you'd find in a single building, like your office Wi-Fi. Go even bigger and you've got a MAN, a metropolitan area network, which can connect different LANs all across the city. And then there's the big one, a WAN, the wide area network. This connects cities, countries, continents, the internet itself. Yeah, that's the ultimate WAN.
And this slide, this is where you see the real trade-off. It's so important. As you go from a small, cozy LAN to a massive, globe-spanning WAN, the complexity just explodes. Your speed usually goes down because of the huge distances. Meanwhile, the cost, the difficulty of maintenance, and the chances of something breaking all go way, way up. This really shows you the core challenge of networking. You're always trying to balance how far you can reach with reliability and cost.
Okay, so who's actually doing all the work managing this traffic? Let's meet the three key pieces of hardware. Let's call them the diligent workers behind every single connection.
First up, we've got the hub. This is the oldest and, frankly, the dumbest of the group. Think of a hub like a digital town crier. When it gets a message, it has zero idea who it's for. So what does it do? It just shouts it out to every single device it's connected to. Super simple, but not very efficient or private, right?
I mean, the upside is pretty obvious. Hubs are cheap and super simple to set up. But the downsides? Oh man, they are huge. Since it's yelling everything to everyone, you have absolutely no security. It also creates a ton of pointless traffic, which leads to these things called collisions, where data packets literally crash into each other. For those reasons, you pretty much never see these in modern networks.
So to fix the hub's shouting problem, we needed something smarter, and that's where the switch comes in. If the hub is a town crier, a switch is like a super efficient office mail sorter. It's intelligent. It learns the unique address, called a MAC address, which is like a permanent serial number for your device, of every single thing connected to it. So when data comes in, it knows exactly where to send it.
Here's how it pulls this off. It's pretty clever. When a chunk of data arrives, the switch looks at where it came from and makes a note. Okay, that device is on this port. Then it looks at the destination address in its internal logbook. If it finds a match, boom, it creates a direct private connection and sends the data only to that one port. No more shouting, no more wasted traffic, and way better security. But here's the catch with a switch. It's a local expert. It's great at managing traffic inside its own little network. To go global, you need something more. You need a router. Think of a router as the global postal service. Its entire job is to connect different networks together, like connecting your homeland to the massive WAN of the internet. It's the master traffic controller that figures out the best possible path for your data to take across the world.
So when you put them all side by side, you see this amazing evolution of intelligence. The hub is just a dumb repeater. It just shouts. The switch is smart, but only locally, like a mail sorter for one office building. But the router? The router is the master navigator, handling mail between totally different cities and countries. Each one is a step up, solving a bigger and more complex problem.
We've met the workers, but how does the information itself actually get around? I mean, what are the physical highways and the literal rules of the road that data has to follow?
Basically, data has two ways to travel. There's guided media, which uses a physical path, a cable, like fiber optics or the Ethernet cable plugged into your computer. The signal is guided down that specific path. Then there's unguided media, which is just wireless. The signals travel through the air, like Wi-Fi or radio waves, spreading out in every direction, hoping a receiver will catch them.
Now let's talk about the rules of conversation, or transmission modes. The absolute simplest is called simplex. And it's exactly what it sounds like. It's a one-way street, period. Your keyboard can send signals to your computer, but your computer can't send anything back to the keyboard. One direction only.
Next up is half duplex. Now, communication can go both ways, but, and this is a big but, not at the same time. The perfect example is a walkie-talkie. You have to talk, then say over, and only then can the other person talk. This is exactly how that old hub worked, which is why it had so many data collisions. Only one device could talk at a time without causing chaos.
And finally, we get to full duplex, which is what we all know and love today. This is a real conversation. Two-way communication happening at the exact same time. It's just like a phone call, where both people can talk and listen simultaneously. This is the superpower that the switch brought to the table, and it made everything so much more efficient.
Okay, we have covered a ton of ground, from tiny signals in a cable to the global brain of a router. So let's zoom out and tie this all together with the big picture.
So if you only remember a few things, make it these. First, networks are just about connecting things to share resources. Simple. Second, as you scale up from local to global, the cost and complexity just go through the roof. Third, the hardware we use got smarter over time, evolving from the dumb hub to the local switch to the global router. And all of this creates a really clear hierarchy. More capability means more cost. And that right there is the bottom line. It's the crucial point. As you climb that ladder from a simple hub to a complex router, you get so much more power and flexibility. But you also have to deal with higher costs and the need for people who actually know how to manage the thing. It's always a balancing act.
So our entire digital world is built on this foundation, on these rules and devices. But I want to leave you with one final thought. What happens to all these rules when the next billion devices join the network? And I'm not talking about computers and phones. I'm talking about cars, refrigerators, coffee makers, everything. How will this whole system have to adapt?